So in the last two lessons, I've introduced you to what a polymer is generally and some of the common properties of polymers. In the next several lessons, I'm going to introduce you to several major types of polymers. And in this first lesson, the type of polymer we're going to talk about is what we call plastics. Plastics are synthetic organic polymers. So the kinds of polymers that we've been looking at in the last couple of lessons are all examples of plastics. In general, plastics are malleable so that after they've been synthesized, they can actually be molded into desired shapes for whatever application they're going to be used for. And this table here on the left-hand side is basically a summary of all the different types of plastics that we have according to their recyclability. So you can see what they are is they tell you the type of polymer, and then the codes over here indicate recycling codes. So from this chart on the internet, you can quite quickly find the structures of all of these polymers. We've looked at several of these already. We've looked at polyethylene. We've looked at PVC. Here's another polyethylene. We looked at polystyrene. So that the only ones that I haven't shown you directly in one of these lesson videos are polypropylene and polyethylene terephthalate, as well as the sort of catch-all category at the bottom of other. So I'm not going to spend a lot of time showing you new polymer structures in this video. I have on the right-hand side here shown you the structure of polypropylene, one of the ones you haven't seen yet. Polypropylene is the recycling type 5, so that means you've seen everything except recycling type 1 now. You can be familiar with all the common plastics. And polypropylene is very much like polyethylene, but it's only got this methyl group hanging off of one of the carbons of the backbone. So we talked about before, polymers are often made up of monomers that make a backbone, and then a side chain sticks off of that backbone. You're going to see that theme again and again and again, where we have some sort of, CH backbone functionalized by the side chain. We saw this with polystyrene, and when we talk about biopolymers in the next couple of lessons, we'll also see this backbone side chain organization is very common. Plastics are often referred to as biodegradable, or many of them are actually not biodegradable. And so as we talk about plastics, I wanted to talk briefly about what it means for a plastic to be biodegradable and why that's important. Biodegradable plastics are those that can be decomposed under some naturally occurring conditions. So the feature that causes them to decompose may be sunlight, which is actually ultraviolet radiation. So if sunlight decomposes your plastic, plastic is decomposed in a photochemical reaction. Some plastics can be decomposed by water. The reaction with water causes them to fall apart. Some bacteria can eat certain types of plastics. Maybe they're mechanically destroyed by wind. If any of those things can happen naturally, so that if we leave a plastic somewhere in the natural world, it will decompose, then that plastic is called biodegradable. But unfortunately, as you see in this picture down here in the bottom right, most plastics are not biodegradable. You have almost certainly visited some place that has a so-called plastic island or a lot of plastic trash accumulated on it. This is actually a picture of Hawaiian coastline. So this ought to be pristine, beautiful, volcanic rock, but you can see that it's cluttered everywhere with all sorts of different kinds of plastic products. Because when we throw our plastic away, it has to go somewhere. And many of you will know that from space, we can now see plastic islands in the center of our oceans. Because of the currents of the oceans, there are particular areas where the plastic simply accumulates. This is obviously a problem long term. It's an environmental catastrophe, we might say. And so there's a large push then towards wanting to create more biodegradable plastics to avoid this sort of environmental contamination. And another way to do this is to take advantage of what we call biopolymers. Biopolymers, as we'll see in the next lesson, are polymers that are not produced using traditional chemical synthesis from petrochemicals, but are instead produced in a biological system, either naturally or via some sort of engineered process. And in general, because they come out of biological systems, they tend to be more biodegradable. They tend to be more compatible with the biological world. And so one of the approaches to dealing with the environmental problems that extensive use of plastic has created is to try to shift us, in terms of industrial applications, to higher reliance on biopolymers. It's with that in mind that in the next lesson I'm going to introduce you to the major types of naturally occurring biopolymers.